Hi there, I'm glad you're here. This is Middle School Math with Dr. Koenig, and today we're going to talk about some angle basics. What to know about angles, why we talk about angles, how do you write things down about angles. There's a lot that goes into it. So let's get started. So let's talk about what an angle is. Now this is a picture you'll often see in your math class. This is an angle that you'll see. It's the space between two lines or two rays that share a point. So in this picture, you'll see that I have two rays. A ray is kind of like half a line. You could think of it like half a line. It starts at a point and it extends out in one direction. Same thing here, I've got another ray that starts at a point and extends out, and the space that we measure, usually in degrees, is called an angle. Let's look at a bunch of different examples like you might see in math class. So this is one example of an angle. This is another angle you might see. And another. And another. One last angle. And you'll notice that all of these look pretty different. They have different angle measures. They have different letters on them. There's a lot to know about angles. And actually, these aren't the only angles you're ever going to work with in a math class or in a geometry class. Here are some others you might see. We work with angles a lot in shapes, in rectangles. Hopefully you already know, you're already familiar with the fact that rectangles have what we call right angles, so they're 90 degrees. You'll also see angles in triangles. There's an important piece of information about the sum of the angles in a triangle, which means if you add up all the angles in a triangle, there's a sum property. You might be familiar. All triangle angles add up to 180 degrees. We also have angles that we see in other kinds of shapes. So this is an octagon. Octagons have much wider angles, as you can see, and a lot more of them. So you see angles all over the place in mathematics courses, but are they actually relevant in real life? In fact, actually, it's really important to know about angles. When somebody constructs a building, they're often looking for 90-degree angles. If you're constructing furniture, you're often looking for 90-degree angles. And in some cases, if you mess up, it could be detrimental. For example, in a bedroom or in a home where you're trying to keep the home standing up straight, you need it to really fight against the shifts of the earth. That's really important that you get your angles just right and your structures just right. Here's another example that's really, really important. Folks that use a wheelchair need a ramp to have accessibility into a building, and ramps have very specific angles that they work with to be accessible. If you make a ramp that's too steep, people in wheelchairs can't actually use it, and therefore the building is no longer accessible. So the angle, the incline of that ramp is very important. Another really drastic example would be a bridge. People who build bridges, people who construct them, and people who design them really need to be perfect with their angles in order to keep a bridge standing up and to keep it safe for not only people to walk across, but also cars and trucks and very heavy vehicles. So angles are actually everywhere, and understanding them is a great lead-in to using them in the future for many, many careers. So let's jump into that. Today we're going to start with the really basic information about angles. I'm also going to make videos about complementary and supplementary angles, which you see all over the place, and vertical angles. There's really a lot to dive into when it comes to understanding angles. So like I said, today we'll start with the really basics. Now, when we talk about angles, it's important that we all have the same method of talking about angles. For example, if I look at this angle and call it angle X, and somebody else calls it angle Y, and somebody else calls it angle Z, we might not actually be talking about the same angles, the same information. So naming an angle is very important, and using the notation is very important. So here I have an angle, and I can name this angle X, Z, Y, or I can name this angle Y, Z, X. You'll notice that I went in two directions, so I could name it X, Z, Y, or angle Y, Z, X, but I cannot name it X, Y, Z. And the reason for that is that's telling me that there's an angle over here I'm talking about. That's not exactly the angle that I'm discussing. So angles can be named in a multitude of different ways. What's important about the name of the angle is that the vertex is always in the middle. Now, in order to understand what I just said, you need to know what the vertex is. So I want you to look at Z in this picture, and what do you think makes that a vertex? Well, in fact, it's because it's the corner of the angle. It's where the two rays meet. It's that point where my two rays are stemming from. So Z is the vertex, which means that Z needs to be in the middle of the names, which is why I name them XZY or YZX. Some people will name it with one letter, angle Z, using only the vertex. And that's okay in many situations, unless we come across multiple angles that have a vertex at Z, in which case we really have to stick with naming it using 3 letters. Let's look at another. So here you'll see a much skinnier angle. I see an angle that both rays stem from B, which tells me that B must be the vertex of this angle. Now when I name it, I know that the vertex has to be in the middle of the name, so I'm going to call this angle A, B, C, or I can call it angle CBA, and as long as there are no other angles that have a vertex at B, I can also call it angle B. Now you'll notice that in each of these examples I'm using this angle symbol. So when we're talking about an angle, we use the angle symbol to notate that what we're discussing is an angle. Now in geometry, you use a lot of symbols. You might say that I'm talking about ray BC, in which case I would say BC with a ray over it. If I were talking about a line that had X and Y on it, I would say line XY. Notation is important in geometry so that you can communicate effectively and efficiently about things. In this case, since I'm talking about an angle, it's really important that I do have the angle symbol in front of my notation. Here's another example. Hopefully you're getting the hang of naming these angles. You can go in 2 directions. You can go J, H, K, or K, H, J. And because I only have one angle here, I could also call it angle H. So I've now come up with 3 names for it, JHK, KHJ, or just angle H. Remember, what's important there is that the vertex has to be in the middle. So if you're going to name it with one letter, it's just the vertex. Otherwise, it's in the middle of those 3 letters. Now there is a little more notation that we haven't really talked about. Each of these angles has an angle measure, and the angle measure has a different kind of notation. If I'm just talking about an angle, this is the notation I would use. If I want to talk about the measure of the angle, I would change something just a little bit. I would say the measure of angle JHK is equal to 135. Or I could say the measure of angle KHJ is equal to 135. But I wouldn't be correct. I wouldn't be using my notation correctly if I said angle H equals 135. So with geometry, it's really important that we're using notation. Just like we needed to use the angle symbol to say we're talking about an angle, we need the M in front of the angle symbol to say we're talking about a measure. Just saying that the angle is equal to 135 is not using the correct geometric notation. We have these groupings that we often talk about when it comes to angle types. So it helps in mathematical thinking to think about how things are similar and different. So we're often categorizing information. Now, we have categories, of course, for angles. That's what I'm showing you right now. The first one that you might learn about is a right angle, and a right angle has a 90-degree angle measure. You'll sometimes see with a right angle a little box right here. That means it's 90 degrees, or they might have just marked in the angle that it's 90 degrees. Those are right angles, and they're really important for structures and shapes and buildings, and all these things are pulled from right angles. Now, if you have a measure that is less than 90 degrees, you have an acute angle. So these are less than 90. And of course, in order to be an angle, it has to be greater than 0. So it's less than 90, but greater than 0. And again, we measure these angles on the inside of these 2 rays. So this in here would have to be something less than 90. In this case, maybe it's 40 degrees. Or it could even be 89 degrees. It could be 89.5 degrees, anything that's less than 90. An obtuse angle is on the opposite side of things. So an obtuse angle, when we measure this angle, is greater than 90 degrees. but it's also less than 180 degrees because that's a different angle type again. Now, a straight angle is this angle right here where it basically looks like a straight line, and a straight angle has a measure of 180 degrees. These groupings allow us to compare and contrast angles that we're measuring, and when we measure the inside, we can categorize an angle in one way or another. Now, the whole point of learning about angles is to use those angles for something. So here we have a problem with multiple angles, multiple degree measures, and we know a little bit about these things now. We know, for example, that we could name this angle right here. We could say that it's angle MBK. We also know that we could discuss its measure, which is 79 degrees, by writing the measure of angle MBK is 79 degrees. And hopefully we understand the idea of naming the angle using 3 letters. This example is a great example of why you might not use one letter. If I wanted to discuss the measure of angle B, you wouldn't necessarily be sure if I was talking about this guy or this guy because they both have a vertex at B. This is a great example of needing to use 3 letters to name the angle and to make sense of it. Now, the question actually asks us for the measure of angle MBG. And if I look at my picture, angle MBG looks like this, which means I need the total measure. And that's a problem that I know how to solve. If I put those two angles together, MBK and KBM, if I add their measures, I'll get the measure of the full angle. So I can say that the measure of angle MBG is equal to whatever I get when I put those two pieces together. So MBK is 79 degrees and KBG is 56 degrees. And if I add those, I can get the total of the entire angle. In this case, I get the measure of angle MBG is 135 degrees. Here's another example that's really similar. In this problem, just like in the last one, we're looking at how to find an angle measure given some information. Now this time I'm given 2 pieces. I'm given that the measure of angle BEC is 70 degrees and the measure of angle CED is 20 degrees. But then I'm given the total of this full angle. The measure of angle AED is 120 degrees. What I'm looking for in this problem is one of the remnants, one of the pieces that makes up angle AED. So I need to take this time the full angle and take away the 2 pieces that I know. So let's do that. So far I know that I have a 70 degree angle and a 20 degree angle, and together those make up a 90 degree angle, which I know is a right angle. From my full angle, 120 degrees, I need to take away this time. I need to take away the 90 degrees to find that missing piece. In this case, if I take away the 90 degrees, I get a value of 30 degrees, which tells me that the measure of angle AEB is 30 degrees. So that was a lot of information. What I want you to take away from this is that angles are everywhere and the study of them is very important. It's important when it comes to construction. It's important when it comes to fashion. It's important kind of in a lot of industries because angles are everywhere and how they work together is how we design and structure our culture and our world. Angles are typically named using 3 points, with the vertex being the middlemost point, although sometimes we do name them using just one letter if that angle is the only one that has a vertex at that point. However, most of the time 3 points is a safe way to go. And remember, we often see special angle types, and we categorize those to help us better understand how they work together. We have acute angles, we have obtuse angles, we have right angles, and straight angles. And that's not all there is to learn about angles. So this is part 1 in a 3-part series. In the next video, I'm going to dive into complementary and supplementary angles. So I hope you'll join me for the next videos. I hope you'll join me in the study of angles. They're really interesting. There's a lot you can do with them. And otherwise, I'll see you next time. Thanks for being here.